let us remind ourselves briefly of how electricity is generated. We want to go into the simple physics of electricity generation as a simple reminder, your elementary physics, okay? So we know that for electricity to be generated, we need a magnetic field, we need a conductor, and then we need relative motion between the conductor and the magnetic field, okay? So it depends on how you combine all of this. So once they are properly combined, you will definitely get your the voltage out of your unit. So as you can see, this is what is producing the feed, and that is what we have in our generator feed. But in that our generator case, what we have was an electromagnet. So this is like a fixed magnet, okay, telling us how it is simply generated. So the magnet, you can see the magnetic field running from the north to south pole. That is one of the components we need to generate electricity, the magnetic field. Then the next, like we said, is the armature, the conductor, okay? This is the conductor, as you can see, okay? This is the conductor, okay? So the conductor A, let's say CDAB, okay, to these two slip rings. Okay, we will explain the function of the slip rings later. So that's the conductor, and this conductor is what will now form the armature in your generator, as we explained earlier, okay, because that is the part that your electricity or EMF is induced into. So now what happens is that this magnetic field is stationary. We don't have it rotating. But this our conductor, CDAB, okay, can be made to rotate within the magnetic field. So from your Fleming's left-hand rule, you know that once a conductor is made to move in a magnetic field, voltage is induced into that conductor, okay? So the direction of induction of that current is what Fleming left-hand rule will help us to determine, okay? So which means that in one instance, you have, since it is rotating, in one instance it is moving DC. In another instance, that same instance, it is moving AB. So when AB comes up, instead of it flowing backward, it will be flowing forward, okay? So which means that we will be having that induced EMF alternating directions, okay, from forward in the upper part of the circle to backward in the upper, or downward in the downward part of the circle, okay? So we'll now be having alternating voltage, which is what we actually want. So the slip ring is the means by which we evacuate whatever that is generated in the armature, okay, out to our load. So this could be our load, or this could be our load. Are we getting it? So now this kind of arrangement is known as the stationary feed, because we have the feed now, okay? These are the feeds stationary on the stator. Then we have the rotating armature, and then we are now evacuating the power or the electricity that we generated from the armature through the slip ring, okay? Slip ring and brush arrangement, okay, as brushes, okay? So that is how electricity is generated. So know that in generating electricity in your generator, three components are required: the magnetic field, which is this one that is running from north to south. We need the conductor, And then we need the relative motion, and that is what is manually provided by this cranking handle, okay, to turn, okay. So in our power station case, the rotating motion is provided by our prime mover, the diesel engine, the gas turbine, or the steam turbine, okay, whatever prime mover that you are using, okay. So that provides the rotating mechanical energy that helps to create that relative motion between the conductor, which is the armature, and the field, okay, which is the magnetic field that will be generated or created by or produced by the main field winding of your generator. So that is how electricity is produced, okay? So you need to put it at the back of your mind that these three components must be present. So when you are not having production of electricity in your facility, it means that one of these three components is missing. Either the magnetic field has failed, or the armature, the conductor, has failed, or there is no relative motion, okay? So whichever that is missing during your troubleshooting, you can detect that at. So let us look at the construction of these alternators now. The construction of the alternators. So in most cases, we'll see that most of the alternators that we'll come across, they are the rotating field alternators, which means that the stator is carrying the armature. That is the area where we get our main power supply from, okay? So this armature, you see that they are designed on wound in such a way that the three phases, they are equally separated from one another, okay? They are placed in the stator slot such that they are separated by 120 electrical degrees from each other, from one another, okay? So that is what you are seeing here now, and that is what we have here. They are wound on the stator, okay? So the three phase, one will be the red phase, the yellow phase, and the blue phase. And like we said, the three of them, they are separated by 120 electrical degrees. So which means, and they are wound with the same number, that is the same size of wire, okay? Insulated copper wire, the same gauge of wire, the same number of turns. Are we getting it? So that what is produced in each of these set of windings, the arrow, the red phase, yellow phase, or blue phase, they are the same thing, okay? So now if you look, you also see that we have the rotating field in the middle. So we also have windings in the rotating field. Are we getting it? So to magnetize this, we need DC power supply from the excitation circuit. So this one is on the rotor. So this is a rotating field generator. So once you have your DC voltage sent into the rotating field, okay? Remember, this rotating field is coupled to the prime mover. That is the rotating mechanical energy. So as the field is rotating relative to the armature windings, you see that voltages will now be induced into these armature windings. Equal, since the windings are of the same wire gauge, the same number of turns, you see that equal amount of EMF, which is this, okay? They are induced into the red, blue, and the yellow phase. So you can see the separation, 120 electrical degrees. And since they are equal, you see the amount of voltage, okay, that is induced on each of them, that they are the same thing. So this is how the alternator helps us to convert the rotating mechanical energy that is produced by the the prime mover, whichever prime mover you are using, into electrical energy. Okay, so this is the three-phase output that we will eventually get out of the armature. Okay, and this one will be available at the output terminal of your generator, which will eventually be sent in your power station, which will eventually be sent to your transmission transformer, okay, and then to your transmission system. But note that, so we'll need a switching system to switch between the generator and the transformer, and between the transformer and your transmission lines, okay? So like we said earlier, that is the second component of the generation station, okay? Second most important component, which are the switch gears. So your screen now, this is the router to this, okay? This one is carrying the field windings. This is the exciter armature, okay, which produces this EMF that is sent to the field winding. Okay, so as the feed is rotating within this, that is, as the feed is rotating, you see that since the feed is cutting across all of this conductor that makes up the A, B, and C phases, okay, voltages are induced into those conductors. So here we can see a coupled alternator. So we have the feed winding, this is a complete alternator, okay? So this is the part, this plate is what is coupled to the flywheel. If it is a diesel engine, diesel-driven engine, okay? Or gas-driven engine, or the steam turbine, or what have you. So here is, if it's a steam turbine, here is coupled to the shaft that comes out of your gearbox. If it's a gas turbine, the same thing. If it's a diesel engine can run 1,005. Here can be coupled directly to the flywheel of your diesel engine. If it is a gas engine, depends on the speed of the gas engine, can either be coupled directly or will have a reduction gearbox arrangement, okay? So that reduction gearbox arrangement will now reduce it to the required speed that we need. If it's 1,005, to take it to 1,500 RPM, that will be required by